Okay, so in this video here, we're going to be talking about how to get the equation of a parabola. Now, this is a little bit different because we're not talking about standard form where you have ax squared plus bx plus c. We're talking about how you can get the equation of a parabola if it's going to be horizontal or vertical. And you can see that I have a table here listing out all of the key features of a parabola. And you can see that the equation for a horizontal is going to be different for a vertical. And the only difference here is you have x equals 1 over 4p and then y squared. And then with vertical, you have y equals 1 over 4p and then x squared. Now, p is talking about your focus. Now, your focus is going to be a distance from your vertex. And your directrix is also going to be a distance from your vertex. And the distance of the focus in the directrix is going to be the same exact distance when compared to the vertex. So they are equidistant from the vertex. And this will make more sense as we go. But again, you can refer back to this table so you understand all the key features of a parabola. But we're going to jump into our first problem, and it will become a lot more obvious as I give visuals as to what is going on here. So why don't we go ahead and look at our first example here. So here's our first example. And again, please feel free to go ahead and go back to that table if you need to, but we're just going to go ahead and go for it. And you can see that I have a parabola here. Now, your first question is that parabola going to be vertical or horizontal? Meaning, is it opening upwards or is it opening up horizontally? Now, this is opening up upwards, or in other words, it's vertical. So the equation I'm going to use there for a vertical parabola is going to be y equals 1 over 4p and then x squared, okay? And again, I'm just grabbing that right off the table. Now, you have to figure out what your p value is here. Now, p is going to be the distance, and in this case here, the vertical distance from your vertex to your focus. Now, my focus is right here, okay? So this distance here, all right, is going to be the same thing as this distance here, which is my directrix at y equals -6, okay? So both of these are going to have a vertical distance of p, and we know that that's going to be 6, right? This is 6 here, and this is 6 here, a distance of 6 going from the vertex, right? So from here, it's pretty simple, right? You know what p is. P is going to be a vertical distance of 6. So all I have to do is take that p, plug it in here, and I get 24. So my equation is going to be y equals 1 over 24 and then x squared, okay? So that's pretty simple, but let's assume that you did not know about this equation here, okay? How would you do this problem? Because it's not just going to be plugging in values if you don't know the equation, right? That's going to be a lot more challenging. And so we're going to add another level to this example here, and we're simply going to derive this equation that you see here, y equals 1 over 4p, and then times x squared. And we're going to derive it because if we do, it's going to give you a deeper understanding as to where this equation is coming from and how you can better utilize it, all right? But here is our answer. It's 1 over 24x squared. But now, again, let's add another layer to it, and let's talk about how we can do the problem if we did not know about this equation. So I'm going to go ahead and get rid of all of this stuff here, and we're simply going to start the problem over. And again, we're assuming we do not know about that equation. But I do know my focus here, right? That is provided. My focus is going to be 0, 6, and my directrix is going to be y equals -6. So we can use the fact that our focus and our directrix are going to be equidistant from the vertex, and that will help us with the problem. And it's going to help us because, for example, if I go a vertical distance from this directrix to any point on the curve, so for example, if I start here and I go a vertical distance to any point on this curve right here, okay, since these are going to be equidistant, this focus going to that same point, those distances there are going to be equal. And so think about how you can use that to your advantage now, okay? I have this point here, 0, 6. This point right here, I have part of it, right? I know the y value, I don't know the x value. So I could say here x, comma, -6, where x could be any x value, right? I don't know what that x value is, but I'm going to represent it with x. And this point on the curve is any point, so I'm going to represent that with x, comma, y. So again, this distance here will be the same as this distance here, okay? So how can we use that to our advantage? Well, we have 2 points, right? And we know the formula to find the distance between 2 points, right? That's coming from geometry. So if I use the distance formula here, and I set both of these distances equal to each other, I can then solve for the variable y, and that will give me the equation of this parabola. All right, so let's go through it. Now, again, the distance formula is going to be the following. We have d is equal to the square root of, and then in parentheses, we have x2 minus x1 squared plus y2 minus y1, and then squared. Again, all underneath the square root. So we're going to use this distance formula to our advantage, and then we'll go from there. Now you want to label all of your points. So for example, I'm just going to call point xy here, x1, y1. And then going from this point xy to this point 0, 6, that's going to be my first distance, right? So I'm going to call 0, 6 x2, y2. And then x, negative 6 will be the other distance that I find. So I'm going to call it x2, y2. So we're going to do it in parts. Okay, so doing my first distance here, I'm going to call it d1. So distance d1. And that is going to be the square root of, and again, we're talking about this distance right here. Okay, so my x2 is going to be 0. So I'm going to put 0 minus my x1, which is going to be x. And then I'm going to square it. Okay. Then I have plus my y2, which is going to be 6, minus my y1, which is going to be y, and then I'm going to square it, okay? And we can go ahead and clean this one up. So distance 1 is going to be equal to the square root of, inside here I get negative x, but then when I square it, I get x squared. I'll put x squared here. And then I'm going to leave this one as a binomial squared, so plus 6 minus y, and then squared. We'll just leave it like that for now, okay? So now we have to go ahead and get distance 2. So to get distance 2, we're going to go ahead and scroll down. And we're going to do the same thing here now, except we're going to be using different values. So distance 2 is equal to the square root of, and again, now we're doing this distance here, okay? So my x2 here is going to be x. So in parentheses, I have x, and then minus my x1, which is going to be x as well. And then I'm going to square it. Okay, then I have plus, well, now I have to do my y2, which is going to be negative 6, minus my y1, that's going to be y, and then square it, okay? So from here, you can see that this right here is essentially going to cancel out. X minus x is 0, and then 0 squared is 0. So this whole part is essentially gone. I'm going to be left with d2, distance 2, is equal to the square root of negative 6 minus y, and then squared, okay? So from here, we want to go ahead and set them equal to each other now, because again, both of these distances are going to be equal. So d1 is equal to d2, right? So now I'm going to set them equal to each other, and I'm going to solve for y. And I'm going to solve for y because, again, I'm dealing with a vertical parabola here. And we know that we represent that equation with y equals. If it was horizontal, it would be x equals, so I would solve for x. But again, I'm solving for a vertical parabola here, meaning I'm going to be solving for y, so it's going to be y equals. So let's go ahead and scroll down. We're going to set these equal to each other now, and we'll go from there. So distance 1, that was the square root of, and then we had x squared, okay, plus, and then in parentheses 6 minus y squared equal to distance 2, that's going to be the square root of, negative 6 minus y, again, all in parentheses, and we're squaring it. So you can see that I have a square root on both the left-hand side and the right-hand side of the equal sign. They're going to cancel each other out, and that's going to happen because I'm essentially going to square both sides in order to get rid of that square root, right? So this will cancel, cancel, same thing here, cancel, cancel. Now you're left with x squared. And what I'm going to do, I'm going to go ahead and expand out this binomial here, okay? So it's 6 minus y times 6 minus y. If you expand that out, you get plus 36. And again, assuming you're doing FOIL here, when you do outside and inside, you get negative 6y. But when you add them up, you get negative 12y. And then doing last, you get positive y squared. So plus y squared. Okay, equal to, I'm going to do the same thing here. I'm going to expand out this binomial by using FOIL. So doing first, I do negative 6 times negative 6, and I get positive 36. Okay, outside and inside, that's negative 6 times negative y. That gives you positive 6y. So I get positive 6y, positive 6y. That will give me plus 12y. Okay, and then doing last, I get negative y times negative y. I get plus y squared. Okay? And so from here, when you're dealing with an equation, if you have the same term on the left-hand side as you do on the right-hand side, they're going to cancel each other out because we know that we're either going to add them or subtract them, and they will end up canceling each other out. So for example, y squared and y squared, they cancel each other out. And then I have this positive 36, they cancel each other out. And so now I'm left with x squared minus 12y equal to 12y. Now remember what we're doing here. We're solving for y. Okay, so think about how you can do this problem here. I'm simply going to add this 12y here on both sides. And when I do that, I get x squared equal to, well, 12y plus 12y is going to give me 24y. And remember what our goal is. We want to solve for y. So my last step here, I divide both sides by 24. And when you do that, you get your final answer. So I'm going to go ahead and write it down here. You get y is equal to x squared all over 24, or in other words, 1 over 24 and then x squared. Same thing, right? And you can see that that is what we had at the beginning, right? So there we go. We just derived it by using the focus and the directrix, knowing that those distances are going to be equidistant when compared to the vertex. All right, so that's essentially how you can derive it if you didn't know those equations. But again, moving forward, you're probably just going to want to use those equations. They're much easier. But now you should have a deeper understanding of where those equations are coming from, okay? And it's pertaining, again, to the focus and the directrix and using that relationship that, again, they're going to be equidistant from the vertex, okay? So that is it. That is how you can get the equation of a parabola. And again, in this example here, we're dealing with a vertex at 0, 0, okay? Sometimes your vertex may not be at 0, 0, and the equations change a little bit, but it's pretty much the same thing. You're just dealing with a slightly different equation for both the vertical and the horizontal if your vertex is not at 0, 0. And I do have videos on that, so go ahead and check the link below. So that's going to do it. I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.